domain of combined functions. This can be a little tricky, but really it's not too bad. We just have to remember that domain means we're looking for x's that make sense in the problem, that would work and give us a real number out as a solution or an answer. In order to be in the domain of a combined function, it has to work in both of my original functions. In addition, if we're doing division, we have to exclude anything that would make the resulting combined function have a denominator of 0. All right, so let's take a look at a couple examples here. We have two very straightforward functions, x squared minus 1 for f and 2x plus 5 for g. Well, if I'm just looking here, there's no fractions to worry about, there's no square roots to worry about, so the domain of both f and g is negative infinity to infinity. That means when I do f plus g or f minus g, I'm just adding and subtracting, my domain would still be negative infinity to infinity. However, f over g or f divided by g means that my resulting combined function is going to have a fraction, right? It's x squared minus 1 over the g, the 2x plus 5. But we can't let this be 0, so what would make that equal to 0? Set it equal to 0 and solve. You'd subtract 5, you divide by 2, and you come up with negative 5 halves. So we want everything except negative 5 halves. That means from negative infinity up to it, but not including, so parentheses, union from the negative 5 halves, again, not including it, up to positive infinity. If we reverse that and say, no, we want g divided by f, well, then this time the x squared minus 1 is going to go in the denominator, right? And we don't want this to end up being 0. So how do I solve that? X squared minus 1 would be equal to 0. Add 1 to both sides, take the square root, and it's either going to be a 1 or a negative 1. Okay, so when you have a square, you usually get two answers. So if I'm trying to figure out how would I write that, one way that might help is to put it on a number line and punch out the parts you don't want, so the negative 1 and 1, and then shade the parts you do. And I see I have three sections, from negative infinity up to the negative 1, union from the negative 1 to the 1, union from 1 to infinity. And again, none of the endpoints are included because that would make a 0 denominator. Let's take a look at one that's a little bit more interesting. What if we have f of x is just a straightforward x minus 3, but g of x is a square root of x plus 4. Okay, well, the domain for f, no big deal, negative infinity to infinity, no restrictions. On g, however, when I have a square root, I need to make sure that what's under here is greater than or equal to 0. That would mean that x would have to be greater than or equal to a negative 4. So I can include the negative 4, square root of 0 is 0, no problem there. Negative 4 up to infinity. Okay, so what about the combined functions? Well, if I'm going to do f divided by g, that would put this radical in the denominator like this. Okay, so now not only do I have to keep this stuff underneath greater than or equal to 0, I actually have to keep it strictly greater than 0 because it's in the denominator. So we're going to just take away the negative 4 part and make that a parenthesis instead. Right? The other one is really interesting. If I have g over f, that's going to put the radical on the top divided by the x minus 3. Okay, well, because we're combining these two and it's going to have to work in both, we know at most we can have this negative 4 to infinity, right, with the negative 4 included. That's the most we can have in our combined domain. But this down here tells me, well, you know what? You can't let x be 3 either because that would give you a 0 denominator. All right, so how would you do that? You go from negative 4, and you can include it this time, up to the 3, but not including it, union from the 3, again, not including it, up to positive infinity.